سلام علیکم قوتابیانی خۆشەویست لەسەر داواکاری بەشێک لەوێ بەڕێز بڕیارماندا بە تۆمارکردنێکی خێرایی وانەکانی وەرزی دووەمی فیزیایی پۆلی 11 سیستەمی ئینگلیزی. طبعاً وەرزی دووەمی فیزیایی پۆلی 11 لە 4 بەش پێک دێ بەشی پێنجەم و شەشەم و هەفتەم و هەشتەم باشە محاولە دەکەین انشاءالله ئەو دیتێڵانەی کە پێویستە بیزانن پێتانی بدەن انشاءالله. ئەوە طبعاً محاولە دەکەین لەبەرەوەی سیستەمەکەی ئینگلیزیە باڵانسێک لەبین ئینگلیزی و کوردەکەی ڕابگرین تا بتواننەوەی بەڕێز استفادە لێ بکەن. زۆر باشە با دەست پێ بکەن لە بەشی یەکەم کا لێرە هیتمان دەتوانین بڵێن یان یەکەم شت کا دەست پێ دەکەین Ch.5 which is about momentum on collision. Basha, what are we going to learn in this chapter, Baba? We're going to learn about momentum and impulse, and then we'll talk about we'll learn about the law of conservation of linear momentum. We'll talk about elastic and inelastic collisions as well. The first thing that we will start with is momentum and impulse. Basha, kata yekam shid dest pe dekan inshallah basi momentum و basi impulse. Bas shtek peshoy dest pe bkin Baba agadar ba lera bablan shtek mane it is called linear momentum. يعني ليرة بابلين أو صالك تنها linear momentum داخل إن شاء الله صالي دابة we'll study something else which is called angular momentum. باشا لويا باشتروها هركاتك وباسي momentum ما كرد بلين linear momentum بلام لبروي ليرة angular مانيا هركاتك دلين momentum ما بسمان linear momentum. زور باش بعد أسببكن what is linear momentum؟ طبعا أقل بيناسك راد أسببكن دتواني بلين linear momentum يكم شد أقرب وكو بيناسة دسببكن دتواني بلين linear momentum. يعني هاد momentum سيمبلكيتي بابا بينوسينو يكمتا linear momentum باشا momentum symbol okay we'll use P for that and there is a small arrow بابلين arrow يشيكسكي لسرع أو arrow كسكي بابا it means it means this linear momentum it is a vector quantity كاتا وكو definition كتسي دتوانين بلين it is the product باشا it is the product باشا the product of the product of mass and velocity باشا the product of mass and velocity كاتا دتوانين بلين بريتيا لسرنزامي لقداني mass و velocity باشا velocity طبعا mass is a scalar quantity بس velocity كليرا فيكتورا لو دتوانين بلين هم زاري direction momentum it is the same as the direction of the velocity باشا direction velocity كي كوبو أوش دبيت direction momentum okay زور باشا أو كو definition دتوانين بلين بريتيا لسرنزامي لقداني multiplication تشو multiplication mass و velocity أو دبيت momentum وكو equation أقد مانه وكو equation بينوسين باشا دتوانين بلين momentum دكاتا mass times velocity باشا أوش دتوانين بلين equation momentum دتواني أرايك لسر بنوسيانا تشاشة شوامان لو درز نابيتن باشا at this point here you could just keep it this way باشا أدي أقد مانه بلين unity momentum يتيا طبعا unity momentum unity mass okay you do know that أو دزاني kilogram unity velocity كاشير is meter per second كاتا دتوانين بلين unity momentum دبيت تسأل لو حالتي يعني SI unit okay باشا SI unity momentum دتوانين بلين it is kilogram meter per second باشا كدلين أو times يعني بابلين أو دو تما بستي times بابا أوش meter per second إيه velocity كي أو دتوانين بلين همكو بيناسك definition همكو equation كي يقدرش تيجي كشمان هي دتوانين بلين استاكا وكو if I ask you a question for example what does momentum depends on كاتا momentum depend كاتا ستشتا شيء دتواني of course according to the equation we can say that momentum depends on two things باشا momentum depends باشا depends on two things باشا on two things كاتا دتواني بلين according to this equation هي كمان momentum باشا depends on the mass of the object دوميشان depends on the velocity of the object أنا يعني تسبابا كاتا دتواني بلين momentum depends on these two things طبعا هو زوزو جرينجا هذه relation كان ينقول like how does it depend on these two things here وده تواني يمكن خالي تارم كاتا relation momentum و mass و velocity كوا are they direct and inverse ما بس ما لا direct أقدوش البيكو زياد كان we in English we call them direct أقر بيكو كم كانوا direct but if one of them increase أو ديك decrease كأو كاتي it is inverse وانيا تماشا شيء ركبابا Griman for example as an example يعني هربا أوش بنوسينو تاني بلين momentum is directly proportional with the mass and also momentum is directly proportional with the velocity ما بس ما ليرتيا Griman for example here let's say the first example momentum we know that the mass times velocity here بابلين mass كمان it is 2 kilogram and the velocity is also 2 meter per second كاتا momentum كده بيتسنى حالتي it is 4 قد ما unit كيتيا it is kilogram kilogram چه meter per second باشە ئەوەی لە بیر مەکە ئێستا what happens if we increase the mass يعني لە جیاتی توی for example if we increase the mass instead of while the velocity is the same لو کاتێکا velocityەکە عینەن شتە ئەگەر ماسەکە لێرە دوو بوو گوتمان بیکەنە چار ئێستا for example or 6 kilogram ئەو کاتی مومنتەمەکە چی لێدە ها ماسەکەمان زیاد کرد times the same velocity ئەو کاتی دەبیتە چێ دەبیتە 12 kilogram meter per second باشە کاتە دەبینی هر کاتێکا ماسەکە زیاد کە مومنتم زیاد دەکات this is called direct. What about the velocity here? ئەگەر ئێستا velocity زیاد کەن عینە شت مومنتەمەکە زیاد دەکات. So when this thing happen of course we can call this one directly proportional. ئێستا کێکی دیکەشتان پێدەڵ انشاءالله کتمان ئەگەر ماسەکە for example 6 kilogram velocityەکە 2 ئەگەر زیادی کەن با بڵێن ئەوش 6 what will happen in this case? In that case of course it becomes 36 kilogram meter per second باشا كاتا according to this we can see that these two are directly proportional هم جارب زانه بابا اگر fraction كتبو قطمان those that are above باشا those are that above the fraction we can call them direct ها هذه اگر fraction نوسي دكه توان لخد fraction شي درست كي باشا كاتا اواني كاله سري fraction ان بيكو هم جارب دبنا direct بس اگر لو دوي بي بابا استا اگر ماسه كان velocity كيف subject لده وده تواني طريقه شديكاش مثلا اگر بيكو بون relation او دوي دبيت inverse اگرش بزيابون بابلن if they're on opposite side but both are above for example the fraction او كاتي دبيت direct اگر it is inversely proportional بتوانين بابلن استاك اگر ليرا بما ماسه كان velocity كيف كما subject let's say velocity ونيا equation كتسيلي دي اگر بابلن cross multiply كي دبيت momentum over the mass ونيا ليرا دا توانين بابا او هاشي بنوسين كاتا هرشتك لسري fraction بو كاتي دبيت direct if something is below the fraction with the other one or you can call this one inverse باشا كاتا inverse كلت حالة شروط ده تواني بالله اگر دو factor كان variable كلت نشتك دي بونا وكاتي inverse لقيك دي باشا for example now mass and velocity are inverse but momentum it is directly proportional to let's say both mass and velocity او زاقاش لوشتانه بيتن So according to this equation يقدوش هي بهم خوش بيتي بلوم ليرا what happen if you double the mass باشا ونتشكو بسيران ليدا كري اگر ماسەکە ببیتە 2 ئەوەندە مومنتم چی لێدێ یان ئەگەر ماسەکە ببیتە 3 ئەوەندە مومنتم چی لێدێ باشە ئەو کاتی دەتوانین بڵێن ئەگەر ماسەکە ببیتە 2 ئەوەندە مومنتمەکەش دەبیتە 2 ئەوەندە like how is that if the mass is doubled ئەو کاتی relationەکەی بنووسە what is the relation between momentum and mass گوتمان direct وانە ژمارەکە لێرە هەر چەندە گۆڕە لێرە بنووسە گوتمان ماسەکە double بوو یعنی just twice وانە کاتە the momentum of course will be 2 times larger یانیش دەتوانین بڵێن مثلا it just increases by a factor of 2 باشا what happen if you make the mass يعني بابلين the mass is halved reduced يعني كم بو ماسك او كاتي جمارك هر صندق بو لجاتي ماسك بابلين لير بونس اگر بو half كواتا momentum كيستا بوتان you can say the momentum becomes half of before ونيا كاتا لخد براكتش شبكوا لجاتي ماسك يعني even لجاتي velocity او كاتي بهر جمارك غورا جمارك لجيدانه بزانم صندقات دارو بي this is how much it can change. أجابة عندك نمونش لسر velocity كش ديني كمان for example استاجر velocity كدبل بيت نوكاتي تماشى قلت مالجاتي relation بيني momentum و velocity كوا it is directly proportional ونيا كاتا أجر velocity كدبل بيت لو حالتي دتوانين بلين سي دتوانين بلين momentum كا it becomes 2 times as much يعني 2 times bigger double the bit أجر velocity كhalf بيت لجاتي velocity كي half أشي داني كاتا دبيته half بس استا يكشيد كشمان هي طبعا هو إضافية اگر بيزاني باشا اگر خراب نيا اگر مومنتمك كونستانت بي يعني نغوري باشا كونستانت باشا يعني momentum is the same اگر velocity كي بكينا half باشا يعني velocity كي double كين دبي ماسكة تيلي بي يعني بعكسه اگر ماسكة كي double كين velocity كي تيلي بي باشا ما قلت ما relationi ماسو velocity كو قلت ما لسري قلت ما relationi او دوي inversely proportional وطبعا قشتك inverse بيبقى نوعي دينوسين بابا باشا we'll say this is called inversely proportional استاجر قلت man ماسكي double كان velocity كده بيتسيلي ببوشرتي momentum constant بباشا كاتا دلين velocity دكاتا يجلسر هل لزي ماسكي دابني اگر ماسكي double بيت نوكات you can see that the velocity becomes 1/2 باشا كاتا دبي velocity كبيتا half of before هتا momentum بزجيريان بكونستانتي بمينيتو زور باشا يكشي دكشمان هي ليري بيم خوشا بيتي بلن and that is the relation between momentum and kinetic energy طبعا هيتس relation تشان لبيني هي دتواني بلن تا حدك بلا تشكا momentum دكاتا mass times velocity ونيا ادي kinetic energy دكاتا which you've studied دكاتا 1/2 mass times velocity squared ونيا بس داقت مان momentum is directly proportional with both the mass and the velocity. with the velocity كاتا أوانا زياد كان momentum زياد دبي كم momentum كم دبي بس ليه رشته شيء جواز معناه تاني بقول kinetic energy is directly proportional with the mass باشا and also directly proportional with the velocity but velocity كتير لسر بابا square لسر أقل لبي كاتا استاك تماشى شيرك أجر ماسكي double كان momentum تيله ده momentum كش double دبي وانيا ليه رش عينشته أجر ماسكي double كان kinetic energy تيله ده it becomes doubled باشا بس جاوز كليرة ده لخالي دوم ده يعني دو 20 بلين لقى velocity أجر ليرة velocity double كان عينا momentum كا double دبي بس أجر ليرة velocity kinetic energy يعني velocity kinetic energy double كان تيله ده بابا طبعا هم زالنا براكتة كي جمارك أحسن دك بوبينو سلبرو velocity كسكوير إي kinetic energy كواتا لو حالتي دبيت تسي دبيت 2 square 2 square إجدكات تسي it is equal to 4 كواتا أجر velocity زياد كاتن يعني أجر velocity double بيتن kinetic energy كا increases 4 times أجر ليبي باشا أدي أجر half بيتن أو كاتي half square دبيت تسي دبيت 1 over 4 كاتا أجر velocity كا ببيتن نيوة kinetic energy أو كاتي decrease دبي by 4 times يعني بابلن دتواني بلن دبيت 1 over 4 أوشتانا بزاني خراب نية وآخر نوت لسر momentum بيشو الركابة كدينة and that is this. Design good man if an object is moving or maybe a few things actually باشا because momentum it is equal to mass times velocity كاتا أجر do object ما نهبو تماشى شو خالي كباب if we have two objects that have the same mass باشا same mass كاتا ماسي وديك they both have the same mass بابلن ماسي كم it is 2 kilogram M1, M2, for the second object, it is also 2 kilogram, basha, 1 kilogram. But if one of them has, let's say, a higher velocity than the other one, basha, kata velocity away is 2 meter per second, but velocity away dika, basha, velocity away dika, let's say it is 3 meter per second. Kata, if they have the same mass but different velocity, أو كاتي momentum كاينان سيلي ده تواني بلين momentumي أو كا velocity كي زيادة momentum كي جورة ترتبي لبرسة نستعمل الناوي equation كي بكاري بينا ليه دلين momentum ده كاتا mass times velocity mass كتوه velocity كتوه كاتا دبيتا تسان دبيتا 4 kilogram meter per second ونيا what about the second one here ده تواني بلين mass كدوه بس velocity كليه رسيه ونيا كاتا 2 times 3 that is going to be 6 kilogram meter per second. According to this, the Twain Bilin, I could do object if their masses are the same but velocity is different. The one with the bigger velocity would have bigger momentum. Because these two are directly proportional. What if we do the opposite? What if I get out if they have the same velocity but different masses? When let's say massi it is 2 kilogram massi duan basha. Massi duan bablin it is 10 kilogram basha but velocity kan and einishta their velocity is both 2 meter per second 2 meter per second velocity yakam velocity duan it is 2 meter per second basha good man is that which one do you think would have a larger momentum? Of course it's going to be the one with a bigger mass by the way velocity kan and same and momentum is directly proportional لقل mass كاتا the bigger the mass the bigger the momentum بوشرتي velocity kan and same بي طبعا اللي رجعنا نشد بلين the higher the higher the velocity the bigger the velocity the bigger the momentum بس بوشرتي ليرة ماسا كان same but أكرنا هاري equation كي بنو سود تواني بلين ليرة momentum دكاتا تسي momentum كده كاتا mass times velocity massa k2 velocity k2 أو كاتي دبيتا 4 ونيا كاتا mass times velocity massa k2 velocity k2 كاتا دبيتا 4 of course kilogram meter per second ماشي بس هذه ليرة momentum كده كاتا mass times velocity massa k10 massa k جورتره بس velocity k عين اشتكاتا becomes 20 ماشي 20 kilogram meter per second. طبعا هتاستا باسي direction اشتكان ما نكتب بس you can use these arrows just to tell which way it is moving. So عادة if it goes to the right we consider that positive, if it goes to the left we consider that negative. I get it north beaten positive, I get south beaten negative which you've already studied that. باش كاكا أجاتن لو تنخالي هبي خرابنيا. كواتا try to know this one. I believe يكشتيت كش بتوانم إضافة كم لسنوي. Sometimes two objects are moving together. How is that? For example, a person on a bicycle. Let's say here's a bicycle. There's a person on this bicycle. Okay, let's just choose something. So here's a person on this bicycle, obviously. You can see that. So this person is moving on a bicycle. Obviously, is that the bicycle has its own mass. Let's just call that M bicycle. Let's say it is 6 kilogram. And then the person riding the bicycle has also has a mass. Bablin massi person P for the person and for the child doesn't matter. Bablin massi person 25 kilogram. So now these are both if the because the person's riding the bicycle kata bicycle velocity here. Let's say the velocity of the bicycle it is 5 meters per second to the right or just positive. Is that if I ask you a question, for example, what would be the momentum of the person? What would be the momentum of the bicycle? What would be the momentum of both the person and the bicycle together? Twanin lira setsar momentum bebina basha zara chando person kata momentum person it is mass times velocity. Massi person it is 25 kilogram. Basha velocity kaman sanda it is 5 kata the twanin bilan it is 125 kilogram. Basha 125 kilogram meter per second. I got no khala nabi basha. What about the momentum for the bicycle? Momentum for the bicycle, B for the bicycle basha. Then massi bicycle okay. E person okay and bablan child okay. And E bicycle okay times velocity of the bicycle by the way. So Gutman massi bicycle okay is 6 kilogram velocity okay it is 5 kata it is going to be what 30 kilogram meter per second basha. Now these are this, but what if the question is asking you to find the total momentum for the person and the bicycle together? Aren't they both moving together? Yes, momentum totally. Both the person and the bicycle it is equal to. We do mass man here. Momentum mass times velocity. Yes. Because we're saying for the total, so that is going to be the mass of a person plus the mass of a bicycle. Do objective if they're moving together, of course, one of them is, let's say, or a person like riding a bicycle or a car, could be whatever. M1 plus massi objective plus massi objective times the velocity. Later objective kaman yakam object man one of them is the person, awedikashan is the bicycle. Now it's the massi person is 25, massi bicycle is 6 kilogram times the velocity which is 5 155 kilogram meter per second. Agad لو خالبي أو دتوانين بلن شتا شي زور جنجا نبي أقعد لبي زور باش دتوانين بلن أو if you know this much regarding momentum, you don't need anything else. Basha? Kata agelo dubarik mo baba gutman. Momentum it is the product of mass and velocity. Momentum is a vector quantity. Kata it has both magnitude and direction. Magnitude mamasman lejmare lebrakea. Basha like how much it is in number. The direction, which direction it is going, right or let's say right, left, up or down, north, south. These directions we're saying here. Gutman equation momentum dakata P for momentum dakata mass times velocity. Basha unit takaitsibu Gutman it is kilogram meter per second. OISI unity momentum. Oshmango Gutman agar do object and velocity and habu. We'll look at their masses. The one with a bigger mass would have larger momentum. Agar massa kan and equal, but look at the velocity. The one with larger velocity would have larger momentum. If we have two objects moving together or stick together, like a person on a bicycle, if we want to find the total momentum, we combine their masses, multiply by the velocity that they have. This is how you can find the momentum. Or you can say these are the main concepts regarding this. Momentum is directly proportional to the mass and velocity. Mass and velocity, momentum زيادة كاتا linear momentum it is a vector quantity defined as the product ما بسمان شيء ما بسمان عادة نماثل كذا product يعني سرنزام يعني بابلون result شيء result multiplication which is obviously here mass and velocity. Equation كيف سيقول مان momentum mass times velocity أو أرجس كان يعني it is a vector quantity that has both magnitude and direction. أقول لي أمبرسي what does linear momentum depends on هم كاد that one equation. كل خد بنسي this would help you even for grade 12 when they say or ask you something what does it depend on. أقول equation هم زال خد equation كي بنسي كاتا mass and velocity ونيا كاتا depends on mass and also depends on the velocity, which these are both directly proportional. But good man, mass and velocity they are inversely proportional. وباسي وش تشمان كقطمان if two objects move with the same speed تماشا چه دكين تماشا ماسا كان دكين the heavier object will have more momentum باشا اقعد لو خالي بقطمان if two objects باشا have the same mass اگر ماسا كان يعني equal بوكاتي تماشا velocity بكت the faster object would have يعني will have more momentum. استاد توانين برسالة زور بسرعي لسروي دل اگر bowling بولك و basketball كمان هبي these are both rolling at the same speed باشا which one of them has more momentum طبعا think about a basketball or the mass of a basketball باشا أنا bowling ball عادة وزنكي بابلين جريانا يعني ماسكي زورة basketball ماسكي كم تري لتسا bowling bowlي rolling at the same speed كاتا velocity كانيان same باشا أجر velocity كانيان same بيتماشا ماسكاني دكين ماسي bowling bowlي زيادة كاتا the bowling ball would have more momentum. عندك study tip مان هي أو study tip أنا بزاني خراب نية استفادان لدكي لبولام داني برسالك أنا قلت مان إسا unity momentum دكاتا kilogram meter per second linear momentum قلت مان is a vector quantity هم زاري directiony أقعد لو خالي بزور قرنجا باشا نبري ماسكالر و velocity vector كاتا دتوانين بلين هم زاري directiony momentum دبيت directiony velocity يعني velocity رويلة چبو directiony momentum كش دتوانين بلين رويلة دبيت كاتا it would be or it would have the same direction. وباسي وشمان قلت مان if two objects move at the same velocity their total momentum قلت مان قد do object مان بيكو يعني if they stick together move together أو كاتي لوي يعني بابلين in order to find total momentum دلين ماسي كم plus ماسي دوم times the velocity باشا. For example, a person on a bicycle has a combined or we can say that on a bicycle has the combined mass of both. That's about يقدو برساري لسر حلقين ضرورينا عندك برساري ديكا زور باش دلت معناها a 2250 kilogram يعني 2250 kilogram pickup truck has a velocity of onda كاتا دتواني بلنو ماسك يلو خلير رابنوسا ماسك كمان سنة ماسك is 2250 kilogram باشا velocity كمان سنة velocity is 25 meter per second. It says to the east باشا ما دام east you know that قلت ما نير north to south to east to west معناها ونيا ما north كا positive تدي كش معناها قلت ما west to south these are both considered negative. استاك بسارة كده لا تسببينه ضل what is the momentum of the track قلت ما momentum طبعا momentum كأنه قال لي direction إيش معناه ده تاني بلين momentum direction كله دوية تاني بلين mass times velocity ونيا mass كمان that is 2250 باشا times velocity كمان 25 فكاتا the answer to this of course it is going to be 5.6 times 10 to the power 4 unity momentum قلت ما it is kilogram meter per second. What about the directions? كها قلت مان أو magnitude دكيتي بركية هذه direction كا قلت مان direction velocity كيلو هر لا يشيبو باشا direction momentum كاش will be the same thing. كاتا دلين this much you could just say due east باشا كاتا it is directed towards east. That would be the direction of the momentum. زور باش. أو برسالش ماني أبزام زور أصلا شتشوي تدانية أو برسالش حل دكين باشا. دلت آزاد of a mass of 21 kilogram كاتا ماسي آزادي سنة it is 21. Riding a bicycle دتواني بلينو ماسي آزادي A for آزاد باشا أوشان M B for bicycle باشا with a velocity كمان سنة it is 4.5 meter per second but it says to northwest باشا و direction كي رنگ بلي northwest positive and negative you don't have to worry about this باشا so you could just write northwest at the end of for example, after the numbers. What we have is, all right, so the first question or the first part says, what is the total momentum of Azad and the bike, Basha, together? Kata, total momentum. We've learned that if we want to find the total momentum, we can say that total momentum, Basha, total because these are two things, Kata, Twanibal Emi Azadi plus Emi bicycle, that would be the mass of both, Basha, and then multiply by the velocity here. Gutman Masi Azadi is 21, Masi bicycle it is 5.9, Basha times the velocity. Velocity كمان سنة it is 4.5 كاتا والله كده بيت 10 والله كده بيت 1.2 times 10 to the power positive 2 with the 20 طبعا بنسي 1200 that is also fine. Man direction change that we like how is it? We could still write the same thing but let's not forget the unit. Gutman this will be kilogram meter per second direction because you could just say do northwest, Basha. Northwest. just keep the same direction and that'll be it. تماشا بشكاني دي كبكة part B دلو what is the momentum of Azad the momentum Azad يو زارة بتني أقال ليبي momentum بابلين ماسي Azadi times the velocity the velocity كان عن اشتكاتا we don't have specific velocity for Azad and the bike so because they both move together كاتا ماسي Azadi it is 21 kilogram باشا velocity كيت سنبوغت مع 4.5 which is we can say that the momentum of Azad is now going to be 94 kilogram meter per second. Good man direction كش northwest. Basha. You could just write this or you could write the whole thing. That would be the answer for that. Now the last part says what is the momentum of the bike this time? تنها يعني بابلن momentum bike كي عينا شت أو زار e by b for the bike. تونبلن massy bike كي times the velocity. Massaka it was 5.9 kilogram times velocity which is 4.5 والله كده بيتا 27 باشا 27 kilogram meter per second قال لي direction كش that is exactly the same as before so we can say northwest باشا this is how you can solve questions related to momentum بسارة كان زوزو راسانا بابا he's لخوت مشيانا أو بسارة we can say these are exactly the same linear momentum in terms of force and time here باليرا عندك معلومات اللي سروا اشتي دمي باشا so for example now let's say if a person is moving right and then your friend is moving ahead of you now you're just going to give them a push so what do you think will happen aren't they going to move faster because they're moving and you just gave them a push in the same direction so they're going to move right faster so we can say that by applying a force on an object that is moving you can change their velocity excuse me you can change their velocity ebasha kata agar velocity bigore because you applied a force now we can say the momentum is changed but there is also one more thing you need to know once you're applying a force like is that a sudden force sudden push or you just for example keep pushing for a longer time but gently so it depends on that one kata we can say that when we apply a force on an object over a period of time that of course can change their motion and if their motion change, we can say their momentum is changed as well. When you press the brakes of a car, the car's momentum decreases because basically the brakes would slow the car down. When kata velocity change bu, madam velocity ke kambu kata momentum ish kambu So, but remember, once you're applying a brake, the brakes apply a force on, let's say, the wheel or the tire, and then you're applying the force, of course, over some time. Kata force and time, we can say, or that can change the momentum. Masha, kata dalan the force of the brake on a information is the same as what I said. The force of the brakes act on a car, so the time it takes to stop depends on how hard you press on the brake. So, for example, God forbid, you press the brake very quickly when you like. لو حالتي كاتا you apply a large force of a very short time momentum كده غورة but if you want to change or have the same change in momentum like you see a traffic light let's say over there that is red so you slowly like slow down or press on the brake gently so you use less force but of course for a longer time until it stops you or until the momentum change bubbling, or you can have the same change in momentum. According to the second Newton's law of motion, which you've studied before, force and bubbling net force the kata say the kata mass times acceleration was good man because of this, acceleration the kata say the kata m times for acceleration here, let's just write it this way for now. We can say it is equal to bubbling v final minus v initial over the time. As in that acceleration here, that's what it is. So now I can put this in a bracket and I can extend the line here and rewrite this one. Kata f net, the kata say the kata mass times. We could just say this, v final minus v initial over the time in here. And of course, based on this, you could just say this one here, you could multiply this into the bracket. That would be mass times v final minus mass times v initial. We can say f net, the kata. Instead of all that, we can say change in momentum divided by the time. We need this one. This is something very important. And this one too, because this is the equation that we use the most. But if you take a look at this one here, and then you cross multiply, we can say change in momentum, or force times delta time, it is equal to change in momentum. This is something very important, change in momentum. Now, this part right here, it is called impulse. Basha, what is it called? Impulse. Basha, and this one here, you can say change in what? Change in momentum. Change in momentum. Kata, what is impulse equal to? Impulse, it is equal to force times delta t. Basha, that is the impulse. But agar libi, impulse also equals to change in momentum. Kata, agar force time tabu. Bisaraka dali kidi got impulse babino. Agar force time tabu, impulse the kata tse. Impulse. Basha, impulse the kata force times delta t. ودوباره اگر change in momentum بتواني بلا impulse باشا it is also equal to change in momentum or يعني جبابلين بتواني بلا m v final minus v initial because that is the change in momentum كاتا هرچانك اللي انا هو اگر ويسد impulse ببينيو دتواني pay ببينيو لبر تسكا impulse بخوي دكاتا force times the time بس لبر force times time كا equal لقل change in momentum كاتا اگر change in momentum ببينيو يعني چه ديتو يعني impulse كد ديتو زور باشا impulse لفيزياء يعني تسبابه دتوانين بلا نقدر بيكنا كردي it is almost like a sudden push for example or the push that you apply on an object over a period of time باشا دتواني والي شيء for example let's say we said that if your friend is walking you just give them a push when that push over the time you can call that impulse باشا and of course that leads to a change in momentum يعني جبابلن ليرة توبا چي باسكيان توبا چي سلي هر توبا قديتن for example it is coming to you at a speed and then you just let's say extend your arm and you let's say hold it or catch it when so once you do that you just the force is applying and bubbling this ball whatever the kind for example is applying a force to this direction so once you apply a push onto the other side you can actually stop it and catch it let's say so that is impulse basha so what is impulse equal to or what are the unit of impulse here according to this equation you can see that impulse the unit of force it is Newton what about the unit of time we can say it is second kata detwani bilin unity impulse dakata Newton second or yagli unit kana well also we can say that because it is equal to this so we can also say that it is equal to kilogram of course mass times or mass over kilogram meter per second as well basha kata we can say this the SI unit or you could just say Newton second or kilogram times meter per second so this is the impulse but now there are a few things I need you to know here that we can write the impulse this way here so impulse gutman force times time the kata change in momentum when this is what I need you to look at it a little bit. Good man, mass times v final minus v initial. This is how you can write it. When I get to start time, okay, that one in impulse and bubbling force is equal to it is equal to mass times v final minus v initial over delta t. Yani jagad mane time okay bino, basha. Good mane time okay bino. Make delta t the subject. Okati the beta m v final minus v initial. Let's set force and between billion force okay. What exactly can we tell about the 20 equation ana the yan babbling low equation ana it's man description 20 billion agar basha agar force okay constant be basha yan babbling what is it called to change yan babbling agar change in momentum okay constant be if you for example want to stop the car in a very short time I get time okay can be no kati force okay large to beat them good man agar you're driving a car and a child just appears out of nowhere. So what do? You press the brake as hard as you can. Like you want to stop the car in a very short time. You have to apply a very large force in order to do that. But, so for example, if you want to change that over a long time, like you see a traffic light, you'll press on the brake gently, basha. In this case, it will change the momentum over a large time. Get time large beaten. The force you need to stop the car, then it will be small, basha. But the shlani aynan should do barab kiulera. Got فرصة زور بكاربيني أو كاتي can stop you in a very short time بس أجر أو فرصة اللي بكارديني for small then أو كاتي this time would be large. Of course دتواني بلنوش سودو قازانزي خوي هي ذكر له حالتي جاهز أو يكالي رجرينجا دمي أو equation بزاني وطبعا this or this doesn't matter, these are both the same thing. كاتشتك معني دتواني بلن impulse momentum theorem باش بابا impulse momentum theorem تيا دتواني بلن impulse دكاتسه باشا يعني قلت ما نوا f times delta t دكاتا impulse ونيا وطبعا vector quantity شا دتواني بلن is measured in Newton second أقل لي per نيوا Newton times second أقل بلك per غلط دبي or kilogram meter per second. قلت ما delta p change in momentum فك force delta t كش time which is measured in second. قد دتواني بلن impulse it is a constant يعني بابلن for a constant external torque it is the product of force and time over which it acts on an object here. وطبعا اگاش لو دوشتي ببابا relation او دواني سي قلت مان force كا if we for example do that this way the cat change in momentum يعني open bracket v final minus initial over delta t kata it is directly proportional with the change in momentum and it is inversely with the time باشا ويكشيد كشي دتواني بلن the direction of the impulse قلت مان direction هي vector it is the same as the direction of the force applied هم زائد direction impulse كي دبي تعين direction أو force كوا apply بوا ببرسارش لسرحل كيمزام كو برسار لسرحل ذكرت سمعنا ضلي a 1400 kilogram car so دبي تماسكه is moving westward أقعد لي بك ضلي westward يعني negative with a velocity of 1 ده باشا كاتا أو velocity 15 دبيته negative 15 meter per second collides with a utility pole باشا نقل عمودة شي بابلن دعم دكاتن it is brought to rest كاتا يعني تيجي دي خيراية كي خيراية كوتا يعني بابلن final velocity كا دبيته 0 because it says brought to rest كاتا أوان we can call this one v initial كذا كاتا negative 15 v final دبيته 0 in 30 seconds وش delta time كي بسارة كده find the force exerted on the car during the collision. How do I know what equation do I need to use? Babylon given anabka that you're given, and also we're given the mass, we're given the velocity v initial and final, so that is mass v initial final, right? And then we're given the time too. This is the impulse momentum equation here. We can say force equal to change in momentum or mass v final minus v initial divided by delta t. All you have to do now just plug in the numbers. Massa command got matter is 1400. V final command sanda it is 0 minus agal libi. Got man liberi pisaraka dala westward kata v initial kish minus liberi dala westward kata negative 15 agal libi. Instead negative and negative at the beta positive agar libi divided by the time which is 0.30 second. Basha. In this case, of course, malira the 20 odu k positive. Basha. And hadbawi labin 20 billion 0 plus 15 Basha divided by 0.13 times but taban 0 plus 15 times 1400 divided by 0.3 walama kida katatan the force that is equal to 7 times 10 to the power 4 agad libi. Man, if this car is moving westward, agad libi, if this car is moving westward, what kind of or in what direction does this utility pole has to apply the force so that it can stop the car? Again, the car is moving this word. In order to stop it, you have to apply a force in opposite direction. If this direction is negative, then the force that the utility pole is applying it is positive because it means in the other direction here. The beta 4 times 7 times 10 to the power 4, and then that is going to be Newton. We could just say do it east or eastward, doesn't matter, Basha. So let's just say eastward. That is going to be the magnitude of the beta direction. Force, okay, you know that force is a vector quantity. زور باش بقى بسعر شحال كان ليرة تسمان هي ضلي a 0.50 kilogram football is thrown with a velocity on the to the right كده to the right يعني positive ضلي a stationary receiver catches the ball and brings it to rest كاتا this one becomes v initial أوشان ما دام ضل rest that'll be v final كده كاتا 0 أوش دبيت time كا what is the force exerted on the receiver باشا because it says the ball is moving to the right. So here's the ball that is moving to the right. In order for the receiver to stop it, it has to apply a force. We can say it has to apply a force in what direction? Into the left in order to do that, right? Because the velocity is to the right. In order to stop the football, they have to apply a force in opposite direction or to the negatives, to the left side in order to stop it. What is the force exerted? Exerted on the receiver. Force and that force doesn't matter. Mass times V final minus open bracket V final minus initial divided by delta T. So now all you have to do is just do the math. Mass command it is 0.5 or 50, doesn't matter. Times V final because it says to the right, I will just put the number in. That is 15 here. When negative man they go west. West you know that it is negative. The negative layer positive lira. Time it is 0.020. Now we can say that the force that is going to be what? You can see that 0 minus on the beta negative 15 times on this, so we get a negative value. Negative value that is going to be 3 and negative 375 Newton. What is what is the force exerted on the receiver? But this is the force that the receiver let's say used when force it is negative 375 Newton. Let's say how much force exerted on the receiver? Force applied on the hand of the receiver, how much is it? Because this one is going to the right, it is the same magnitude but opposite direction. This force is it is 375 Newton to the right. To the right. In order to stop the ball here, you have to apply the same force but in opposite direction. We found how much force the receiver is applying on the ball to stop it. How much force negative 375 Newton بس force the receiver apply the is to the left. Force لسر receiver the beta magnitude, same magnitude but to the right because direction motion it is to the right. بسارة شمان هي بسارة شيء طبعا لتواني بلين كيتك نبي تركيز ده بيتن لو بسارة so that we can solve this question. Solve it inshallah to do it there right now. Concept شدي كيان, of course we'll do that the next lesson inshallah or session. But before we do this, so that we have enough time, let me just bring this one here. So what does it say? It says an 82 kilogram man, so that would be the mass of a man. It says drops from rest. We can say V initial is 0 on a diving board which is 3 meters above the surface of the water. So here's we can say there is a diving board here. So here's a diving board. Here's the water. This diving board we can say that it is 3 meters high. So this distance or this height, it is 3 meters. So here's the man on a diving board. His mass is 82 kilograms. His initial velocity is 0. That is before he's jumping, right? So now he's going to jump onto or into the water. Okay, and then, all right. So the question says above the surface of the water and comes to a rest 0.55 after reaching the water. So after reaching the water, let's say, it is going to come to a rest. So V final, you can say it is 0. But what is the time that it takes? That is 0.55 seconds. But that is how long it takes after reaching the water. And 0.55 seconds. It is going to enters the water. Then it takes 0.55 seconds to stop. That is how much it requires. What force does the water exert on him? So this man clearly applies a force downward on the water. So the water is going to apply a force on the man upward here. But how much force is this? There is one thing I need you to know. in order to know that for momentum we need both initial and final velocities here. قبل ما اوصل الى initial كمان صفر بو final كش صفرة. So what exactly the change in momentum? And what is the force? Is that zero? The answer is no. Later, you have to do two things here. Man, later, starting from, for example, starting from zero, this man is going to jump, right at this point here. So this is the point we can say that this man is going to enter the water. So we need this velocity that the person that is entering the water with, Basha. So you can say the velocity that the person enters the water, Basha. So this is going to be V initial for entering the water, because now we're only concerned about this part in here, the velocity before and after entering the water. Like right before enters the water and then after it enters the water. We know that after entering the water, that is V final, right? It's zero. But what is exactly the velocity right at this point here? Basha? So how do you know the velocity right at this point? Actually, it would be best if we just do that right at the surface of the water, because that is the height in here. Hi, remember the four equations of motion that we studied in term one? We have the initial, Basha, we have the height, and then we also have gravitational freefall acceleration. Can we find what is the velocity right before entering the water? Sure, let me rewrite this one perhaps. This is 3 meters, we said, Basha. So let's say this is the surface of water. We want the velocity here right before enters the water here. That is going to be V final for this path right here, Basha. So starting from V initial is zero. It's almost like starting at this point, what would be the velocity right here? Because then from this velocity, it is going to enter the water with, Basha. And then we want this velocity and then final velocity, which is already zero, we said it. Then we have the time we can find the change in or how much force is required. So first of all, I need to find this V final. You might say, what is this V final? Because this V final here, it is going to be the V initial for the person entering the water. We have, or we're going to use, because we have the distance too, we can use the fourth equation to find what is V final, Basha. So at this point here, we can say V final squared, it is equal to V initial squared plus 2 times gravitational acceleration. We can say delta Y. Don't forget this. So V final, it is unknown here. So V final squared, the V initial, it is 0 squared, doesn't change anything. 2 times gravitational acceleration, it is negative 9.81 because it is moving downward, or gravitational acceleration is downward, and then delta Y, this 3, because it is moving downward, that is also negative here. So now, of course, you can use a calculator now. We can say V final squared, the kata 10, 2 times on the negative, the beta positive kata, 2 times 3, that would be 6 times this much. Let's get a calculator and answer this or see what exactly this equals to. As a matter of fact, here, we can see that, and then whatever the answer is, we don't have to do that, and then you can take the square root for both sides. So V final, it is equal to what? V final, it is equal to negative 7.67 meter per second. And the reason why negative, because it is pointing or falling downward. Got that. This V final, it is negative 7.67, right? Yes, that's what it is, meter per second. But look, V finally, this is the velocity that is entering the water with. So we can say now, this final velocity becomes the initial velocity for what? For entering the water with, Basha. Kata, this V final, it is the same as the V initial for entering the water. V final, it becomes 0. Now, Kata, V final at this point now, we can find the force now. Let's use this color. Now, the net force, the mass times V final minus V initial, let's say delta TK. Now I can find the force here. So, instead of mass person, it is 82 kilogram times, Basha. V final, it is 0 minus V initial, it is negative, negative, the beta, positive 7.67, and then close the bracket. Now you can divide by the time, which is 0.55 seconds. Now you can find the net force, the beta positive, and the answer is going to be 1144 Newton. And you can see positive here, that means it is upwards. Got that? This is how much force the water applies on the person in order to stop it. Basha? It is falling downward, so in order to stop that, you have to apply a force upward, which is going to be, in order to stop the person from falling further. Basha. آخر پرسیار بیتن وابزان مهانی دیکش تچیوانیه. Just do the questions, you could find them or do them very easily. Next time, inshallah, we'll talk about stopping time and distance, which also depends on the momentum and theorem, which I believe we already sort of, we talked about this. Till next time, keep practicing and I'll see you soon, inshallah. Assalamu alaikum wa rahmatullah.